I love astronomy, and through the technology of today, we can peer into the outer expanses of the heavens. But out of the countless stars in the cosmos, surely there are other planets. And out of those planets, wouldn't there be many like Earth? Have we found life on other planets? We'll find out on this episode of Wonders Without Number.
To give an example, one of the first ones done this way was the planet at PSR B1257 plus 12. I mean, that's
what a lovely name.
Rolls off the tongue. It's actually coordinates for a pulsar.
Okay.
A pulsar is a very rapidly rotating neutron star, which is very tiny. We believe these were produced by the eruption of a particular type of supernova explosion.
Okay.
And back in 1992, they found 3 terrestrial-like, those are Earth-like planets, orbiting this pulsar. From this method. It was amazing they were able to figure this out. Here's the problem. How did those planets survive the formation of the pulsars?
If it's caused by a supernova,
Oh, I think it would have blown the planets away.
Sure.
And it's always been an enigma. How do you explain these? Did they form after the pulsar was formed or what? You know, that's a tricky one. And nobody seriously believes that there's life possible in these because the radiation, it's been cooked. It's a mess. But, you know, it was the first confirmation of extrasolar planet, even though it was one of the most exotic type stars you can imagine that it was orbiting.
so in other words, stars actually differ quite a bit one to another.
Oh, yeah.
And in fact, and our sun would be a main sequence G-type star,
Right.
which classifies that type of star. But I think I do read something in Scripture that says that one star differeth from another.
Writing to the Corinthians, Paul talked about that. All stars are different, as it turns out. But anyway, the minimum mass of this, again, a little uncertainty, is about half that of Jupiter. And that, too, is also a problem. We don't think Jupiter-massed planets can support life as we know it.
Okay.
There are problems with the atmosphere and all sorts of things. But it's not a good candidate for life. No one thought so. But again, it's actually observed and found. It's very close, too close. And then there's another way we can do this. We can also look for what we call transits. If we're in the line of sight, the orbit is edge on. Every time the planet comes around, it's going to pass in front. It's going to eclipse or transit. We call the transit since it's smaller, but it's like an eclipse. It's going to block it out. Now, I've done eclipsing binary stars, and we observe transits on those all the time. So this is something I know a bit about, but it's I don't do planets, but I do binary stars.